with that, I will be turning it over to Aleksandra to take us through an update of the PHYtx work on FTTdp.
Lincoln, thank you very much. Let me share my screen first. Hello, everyone. Today's speech will be about many acronyms and many numbers and the numbering conventions we use in the FTTX. So let me just quickly go through the intro page so you can have a kind of understanding what's going on there in this FANCE project stream within the physical layer transmission work area. This is one of our latest projects and the project stream that have been started probably like 3 years ago. It's about fiber access network copper extensions. The focus is on development of technical documentation for the deployment of copper transmission technologies that extend fiber networks to end users utilizing the existing copper infrastructure at the premises. So basically, one of the first projects there was, and this is the story about the numbering in acronyms, was TR301. Where a node type that supports very deep deployment of fiber-like services in the access network through the use of G.fast or VDSL2 was basically defined. And this is, I would assume, something which is already very well known also in this Australian region as a kind of architecture document for the deployments based on G.fast and VDSL2. Leveraging the 301 architecture and requirements for FTTdp, another acronym, we have another one, pretty new and very soon to be released, the first issue of TR419. This is a document and a work that builds its fiber to the extension point architecture, FTTep, another acronym, which is a fiber extended by a copper medium using different underlying copper technologies. Traditionally, we were always having in mind the G.fast from ITU-T, but it is also ITU-T G.hn and also MoCA. And all these combinations and extensions of fiber-grade services is basically to provide something very similar and comparable to the FTTH without causing significant degradation in QoE. So this is a story from or our basically evolution from FTTdp to the FTTep. This first document and the first work, as you can see here, started 5 years ago. That was our first kind of basic building node for the architecture of the FTTdp. We have several, of course, revisions, improvements there, and ended up basically with hopefully next week's announcements about the release of the first issue of TR14, which will be also followed by a kind of document which is more related to the market positioning of our technical work TR, and this is basically the prefix MR, like suggesting it's a marketing report, and this is basically really providing answers to the main and key questions related to the reason for utilizing existing copper infrastructure for deployment of fiber-grade services. As I said, this is I would hope so, very well-known work of the BBF. I will just briefly go through the main bullets here regarding the really main points of the 301 and wouldn't really suggest any further details readout really based on the officially released BBF document. So this 301, as I said, defines the requirements for distribution point unit for use within the access network, within the framework of two famous BBF architectures, and this is TR101 and TR170A. The work on this architecture concept was started 2006, so you can see almost I don't know how many years, 14 15 years of work in this area. So we gradually basically developed this whole concept of architecture, plus adding on this more and other requirements regarding coming closer to the end users and achieving FTTH fiber grade like services, as I said, in the last 10 to 15 years. I would say the main issue or the main point to remember here is the uplink. Uplink side includes point-to-point gigabit Ethernet and 10 gigabit Ethernet point-to-multipoint fiber technologies developed by ITU-T, and of course in the drop part or in the access part of this traditionally use of VDSL2 and G.fast copper drop. I have listed here a few of the typical FTTD deployment scenarios. I would not really like to go into details, and this is not the point of today's presentation at all, but this will give you a kind of a feeling that this is pretty much very powerful offer on the different deployment scenarios that could be addressed by using the concept of FTTdp. So something about the main features from the perspective of DPU sizes. It's really covering almost everything, starting with the single line DPUs and going up to the large multi-line DPUs and even larger than this. In this document, we also cover different powering concepts. I will just mention one, and this is the reverse power, where the DPU is basically powered through or from the customer premises side via the copper lines. And this is the work in which we heavily rely on the work of ETSI ATTM TM6 group. This is the group where basically the reverse power specification over twisted pair has been defined. This is the one mentioned here, 5448-1. And the guys are currently going into the finalizing process of defining the second issue or the second version, which is RPF over coax. So you will see that then basically with the concept of FTTdp and in general broadband forum architectures and work on this, we are really bridging 2 or 3 or even more, of course, these SDOs, and in our particular case, it is very much alignment between the ITU-T, ETSI, and BBF. So these are other main features like voice support, hybrid DPUs, remote copper reconfiguration. I will just mention this one because it is really something that gives a very high level of practicality and usability and simplification of the evolution of the classical CO-based services or cabinet-based services and connections to the DPU-based services. So I think this is something that service operators appreciate very much. Then regarding the migration scenarios, there are several of them, and I really do hope so. I haven't checked the list of participants or attendees this morning, but at least if there are at least one, two, or maybe hopefully more service operators from the Australian region or Asian region, I guess you will find yourself some kinds among these four migration scenarios in basically in which we are giving a kind of recommendations. Of course, it's your decision how to deploy this, but in recommendations of as of what would be a kind of a typical way of moving from the VDSL2 customer basis to a G.fast customer basis. So I think this is very well covered in 301. I would recommend you going into further details by yourself if you're interested, of course. And in this 301, of course, we also cover a kind of part of a network looking towards the northbound interface into the high order nodes and in general providing the requirements for persistent management agents. And there is, of course, requirements on the backhaul and interoperability with these three types of ONUs, which on the same optical distribution network, which is basically kind of guaranteed by the work of BBF architects on the whole picture of FTTdp. So that was almost everything I wanted to let you know tonight, or tonight my time, this morning your time, including this typical deployment models. And now would like to draw your attention to our very, very latest piece of work. And this is this DR419 about the fiber access extension over existing copper infrastructure. So there are so many problems or challenges. You can look at this into the challenges in the fiber deployments in brownfields areas. It is really absolutely very complex to provide FTTH broadband connectivity for many reasons. For the reasons of, I just mentioned few, labor costs. It is disruptive to customers. It is sometimes a very slow process of getting permissions for laying the fiber cables. It is there are many restrictions in the way of how the communities and local authorities are basically willing to kind of allow to provide this FTTH from the scratch. And of course, the demand for high data rates is really something that is absolutely unquestionable. We live this COVID time, I would say, and each day of this is giving us a kind of more reasoning for working even more hard on providing high quality of experience, good service, a service that basically fills demands of the customers of having almost everything virtualized. So to simplify deployments in all these situations and to lower the costs and the complexity of deploying FTTH networks, 419 is basically a tool. It is aimed to provide evidence of different possibilities to address barriers to broadband access by, I don't want to say simply reusing the existing copper, but the idea is really such a simple deployment is obviously more complicated than just this. But this is something that really builds our, I would say also for the FANCE, for this project stream and for the FTTx work area that builds a kind of a framework, I would say, for the next few years to really go much deeper into details and start building upon this first issue of 419. So in this current work, we have basically covering, or we have covered the possibilities of extended fiber-like services by using underlying copper technologies, MoCA, G.hn, G.fast. And I think in the next slides, I would like to just give you a kind of picture about the structure of this work, of this document, technical report. So basically, we have one main part of a document where we have collected a kind of a representative number of, I'm not quite sure, but maybe 20 plus of representative use cases. And in the main focus in this main part of a document is basically on a kind of systematic view on architectural management operational aspects of FTTP based on these groups or representative groups of use cases. And then in the three appendixes to this, you could find, I would say, very useful implementation guidelines for FTT deployments with the focus on these specific underlying copper technologies. So this is the general architecture. Just a kind of a very briefly, with the minimum touch on going into details view on this, would be that basically what the overall network from the optical line terminal termination OLT to the end users includes are basically three subnetworks: optical distribution network, copper distribution network, where we talk about these three copper-based technologies for the PHY layer, and the home distribution network, which is really a kind of a final drop and the last drop to the equipment, to the end user's equipment. So few use cases from these 20s I mentioned, or 20 plus. I tried to summarize based on the type of a service area, type of infrastructure. It is really just for your illustration. So I would say the main part of the use cases are related to the MDU shared copper network outside the living unit, which can be, of course, over twisted pair or coax. And in doing this, you can also see that we have, as a kind of a starting point, or as a kind of definitely part of the set of use cases, so these traditional FTTdp services, which have been basically built upon 301. And the next two typical categories are MDU individual copper cable outside the living unit, mainly coax, and this is mainly point-to-point for high-speed internet access or a combination with the set TV. And the interesting use cases where ITU-G.hn technology is used very much as part of this underlying PHY. This is single-family units, individual copper cables over twisted pair or coax. So I think it's really a kind of a huge span of possible use cases that are building the concept of FTTdp. So what can we say about deployment scenarios? This is really a kind of going much deeper in the network, or you can say it one much closer, near to the end users, either outside or inside the building. And of course, depending on the copper infrastructure, that in turn determines the appropriate technology to use. And these are 3 of those. In the next few slides, I have a little bit of information regarding deployment scenarios. And this is basically a kind of typical location of the FTTep point, FTTP fiber to the extension point. These are a kind of typical use cases for the outdoor deployments. For instance, this FTTep outside outdoors free would be something which is FTTdp kind of DPU deployment, where the distance from the DPU to the customers to the premises is something like 200, 250 meters. And then, of course, when we go indoors, then you see that this is something which is related to a typical MDU buildings and MDU topology known from the, for instance, MoCA deployment. So all of this equally can be addressed by using the FTTep. I have 3 examples here for you. And each of the example basically shows the use of different copper technology. So the first one is FTTep 03 use case with G.fast. So this is a kind of almost DPU-like deployment and providing the high-speed internet access on the point-to-point telco grade twisted pair. So this, you can call it G.fast, typical G.fast case. So we know the elements which are very well known from the FTTdp deployments. This is really nothing new, but maybe interestingly just to mention that in 419, we are also trying to generalize terminology. So instead of using a kind of typical G.fast like terminology like DPU, here there is a new term which is optical to electrical unit. And basically 419 is really trying to go into a kind of a level of the overall architecture, and from that perspective there is also a big chunk of definitions and abbreviations at the beginning of the TR419. The next case is MoCA access use for coax cabling coexisting with cable TV and DOCSIS. So this is a typical MDU case, as I said, providing cable TV in coexistence with DOCSIS over the same cable in a typical MDU topology. And the last one is the one I mentioned. This is a use case where G.hn access is used to provide the data grade to provide the service over the twisted pair or coax to the single family units. In this particular constellation or topology, it is about multiple point-to-point connections to the multiple point-to-point SFUs. So this is something which very much remind someone to the G.fast DPU. In this case, the name used for G.hn access stacking of a single O2Es is micro DPU. And there is also something which is kind of similar to the basically capabilities of G.fast to mitigate crosstalk interference. There is a kind of crosstalk mitigation algorithms running in the cloud. So I would say that would be all from the perspective of trying to answer in a few minutes about what is FTTep, how it is built, how it is described in 419, why it is useful to read it and to discover if you have your own deployment that can be basically done based on this recommendation and architecture principles we are trying to provide you in this first issue of this work. So basically, I just want to summarize what are the prospects for FTTep. That's basically usual question, what comes next and why is it important for the future? I would say first factor is, of course, time to market. And there's undoubtedly that this is something, this approach is kind of approach that really saves you time and gives you flexibility. It's quicker, it's cheaper. The cost and complexity of placing fiber deep inside the living unit can drastically increase time to market. It is very complex. Operators need additional options, of course, in the MDU deployments to complete fiber rollout, and of course to be in a position to offer other additional services to customers in a, as I said, cost-effective and a quick manner. We were talking or making jokes initially at the beginning of our work about how we can define the acronym in a better way than just saying it's fiber to the extension point. And then one of the colleagues came up with the idea that basically FTTep is fiber to the most economical point. I leave it up to you and to the service operators to deploy the service in a way that it will really be the most economical point for them and for the customers and the end users, of course. So what we are trying to do is, of course, to go on, and we are already initiated issue 2 of this project. At least these 5 bullets is something that was agreed to have a kind of place in the scope of this work. I think we definitely need to cover new use cases, including wholesale and including 5G FMC. And as Lincoln mentioned, basically, we heavily rely on the contributions of service providers and vendors. And please, guys, come to BBF and participate in this work, because without your use cases, it will be obviously more difficult to basically proceed with this work and provide more new information and different aspects of FTTep that are not covered yet. One of these aspects is, of course, looking into the PON fiber access extensions or P2MP. This is definitely a must to do. We also have some remaining use cases that did not make it to issue 1 from the perspective of deployment guidelines. We also see a need for architecture requirements, of course. And one of the things that's really opening up doors for the next years, and I would say many years of deployment, is that there are new access technologies. For instance, G.fast just came out of a door of ITU-T. There is next generation of MoCA access. There are improvements in G.hn for support of, I just mentioned it here, 10 gigabits PON access extension. So it is really a kind of a framework that will basically gradually be developed also in the future. So from that perspective, my personal view is there are excellent prospects for FTTep. At the end,